All right, we ran through quite a bit of information in the previous slide, the relationship between E and K and delta G. We're going to put that into action for this next problem here using the Nernst equation. So using concentration to determine voltage. This is a really interesting problem, I think. Okay, what we have here, we have two cells, same substance, different concentrations. The more concentrated solution will pull electrons from the other. So the electrode or the plate in the solution will deplete. So let's take a look. And both of these are going to be nickel solutions, nickel 2 plus. And the plates are nickel in each case as well. So they're really identical. They both have nickel solutions and they both have nickel plates, electrodes. And I've got some voltmeter thing hanging out here. As far as the only difference between them, this solution is 1 times 10 to the negative 3 molarity, and this one is 1.0 molarity, standard. Having this scenario based upon what we're writing up here, it says the more concentrated solution will pull electrons from the other. Okay, so it looks like electrons are going to be moving in this direction over to this plate. So if you kind of start using some intuitive logic, if the electrons are all kind of gathering over here, this nickel solution is going to be pulled out and plate out onto the outside of this plate here. And then this one, the electrode will deplete over here. And if this one's going to deplete, I should write that in here, the other electrode over here, this one is going to be depleted and it's going to be going into solution because it's losing electrons from the plate. So the concentration over here is going to increase and the concentration over here is going to decrease until they are balanced. Find that equilibrium. So let's talk about as far as what's happening where. At the anode, and again, as far as identifying which is which, anode happens at the location where you're having oxidation. And oxidation means you're losing electrons. So looks like losing electrons here. This is the side with oxidation, and therefore that is the anode. That doesn't look like anode. Anode. And therefore this side, I guess, is going to be reduction because we're gaining electrons. And this, therefore, is going to be the cathode. Okay, so let's continue with this. So I have nickel, which is going to be turning into nickel 2 plus. And then over here at the cathode, I have nickel 2 plus, which is going to be gaining 2 electrons. I forgot to put my 2 electrons here. 2 electrons and turning into nickel. And based upon who's who and as far as which concentration I have here, I'm just going to be a little more simple. This one is going to be the dilute solution, and this one is going to be the concentrated solution, based upon what I described here as cathode and anode. Okay, now this is kind of weird. When we're putting this together, what is actually happening? So if we cross off things that are common to both sides, we can get rid of the electrons too. And this is going to be weird, so I'll apologize ahead of time. I have nickel turning into, wait for it, nickel, which doesn't make any sense. Let's be a little more specific. Concentrated turning into dilute, in regards to how the electrons are kind of changing place from one side to the other. So the concentrated is going to be compared to this, and I do this for a reason, to kind of set this up. We said we're going to use the Nernst equation for this problem, and here we go. This is where the magic starts to happen. E is equal to E standard minus 0.0592 over N log of products over reactants. Dilute over concentrated. Okay, so if we put in the values that we should, under standard conditions, they're both 1 molarity, it would be 0. And then this part isn't going to change, 0.0592, over the number of electrons changing place is 2 moles of electrons. And then the log is going to be 1 times 10 to the negative 3 over 1. And if we do this, the value we would get, the math, 0.089 volts. Oops. That is our answer. So this being positive tells me it is a spontaneous reaction. Any positive voltage indicates for that particular set of circumstances, the reaction is spontaneous. There we go. All right, we're going to step away from this for a couple minutes and go back over to our notes, or excuse me, homework problems. We're going to cut this a little bit short. We've got lots of stuff going on here. We have 4 equations, and we want to write balanced chemical equations for the oxidation of iron by thiosulfate, by nitrous oxide, and VO2. VO2, we're going to ignore that one. So we have to set up 3 different equations. So write the balanced chemical equations for the oxidation of this by these 3 substances. Okay, so we want to set that up for some equations showing that we're going to have the oxidation of the iron. So iron is going to be losing an electron. And again, I have these equations up here that I can work with to set that up. We're going to have, to start with, iron, 2 plus, to 3 plus, plus an electron. And I'm going to do, again, with the thiosulfate. And the electron being gained or lost has to be on the opposite side. It can't be on the same. So I'm rewriting the equations as necessary to satisfy this set of circumstances. So this electron is on the right-hand side. This electron has to be on the left-hand side of the arrow. Okay, now I have to balance this based on the number of electrons because I have 2 here. I have to have 2 up here. And now I can put the whole thing together. So again, balanced chemical equation. If I do that, I get 2 Fe2 plus S2O6 plus 4 hydrogens, producing 2 iron 3 pluses plus 2 sulfites. or sulfurous acid, excuse me. All right, that part's done for that particular problem. Now we'll move on to the next part, and it asks us to do the same thing, but this time with nitrous oxide. And for that one, do the same thing, in which I have the iron. Excuse me if you can hear my dogs barking. It's always the one. The one barks a lot more than the other. All right, so same problem. I got 2 electrons, so I have to put 2 electrons up here. Putting the 2 together. There you go. So that part's pretty easy as far as putting this together. We've got several more steps to do for the rest of this problem, but we will bring that up in the next video.